In London, 150,000 people an hour disappear into the bowels of the earth and then resurface later at some other location. Like moles, they travel along an extensive network of subterranean tunnels which runs the length and breadth of the city and is more than 400 kilometers long. 408 escalators and 112 lifts take the masses down into this modern underworld and bring them back up again. This is the London Underground, the oldest subterranean railway in the world. People first descended into the depths of their city many centuries ago. The catacombs in Rome, for instance, served the Christian communities as a cemetery and, in times of persecution, as a refuge. The ruins of ancient water and sewage systems also bear testimony to man's early knowledge of tunnel construction. The ground in Paris was also burrowed into long before the metro was built. In the Middle Ages, construction material for the city was obtained in Paris itself from subterranean quarries. Fundamental technical experience of digging tunnels and galleries was gathered over many centuries in the mining industry. But modern tunnel construction did not get underway until the 19th century, when the age of industrialization made the swift mass transport of people and goods increasingly important. So it was no coincidence that the first underground railway should be built in London, because in the Victorian era, Britain led the world, especially in the field of technology. In 1720, London already had a population of 750,000, and in the early 19th century, the Industrial Revolution and worldwide trade with the colonies saw the British capital grow even more. Around 1800, the million mark was reached, and by 1851, London's population had risen to 2.7 million. It's estimated that even around 1850, some 750,000 people were already streaming into the city every day to go to work. But all railway lines ended in a ring of terminal stations on the edge of the city centre. Companies were not allowed to take their lines any further. So people made their way through the centre of London on horseback, in carriages or on foot. It wasn't long before traffic became such a problem that it was seriously impeding the city's economic life. A solution was urgently needed. In 1850, Parliament decided that some of the traffic had to be moved underground. For entrepreneurs and engineers, this was indeed a bold venture, especially as it had never been tried before. Subterranean travel calls for a railway. When plans for the underground were drawn up, it was just 20 years since the London and Greenwich Company had opened the first steam train line in the London area. Yet by the mid-1850s, a national rail network had been built up. When the Metropolitan Railway Company started work on the London Underground in 1860, the engineers used a tunnelling method known as cut and cover. It was the first time it had ever been tried for traffic tunnels. The method involved cutting a trench about 10 metres wide and 6 metres deep, reinforcing the sides with bricks and adding a roof. Naturally, this method caused considerable damage to existing structures. To avoid the expense of destroying private property, most underground lines followed the course of streets. So for years, the huge building sites merely added to the congestion. On January the 9th, 1863, only 2.5 years after work began, the first section of the London Underground, between Paddington and Farringdon Street, was officially opened. At long last, the Metropolitan Railway had established a link between the most important terminal stations. The new means of transportation was an immediate success. It carried 9.5 million passengers in its first year and as many as 12 million the following year. By 1884, the underground ring in the city centre was complete. Even today, it is still known as the Circle Line. Like their counterparts above ground, at first the underground trains were pulled by steam engines. But ventilating the tunnels and stations was proving a major problem. Although ventilation shafts were installed at regular intervals, steam and soot were an irritation for passengers and blackened buildings near the lines. 20 years later, a solution was to present itself. First, though, the method of building tunnels changed. In the last third of the 19th century, the cut-and-cover method gave way to a cheaper, innovative alternative, the tubular tunnel, pioneered years before by French engineer Marc-Isambard Brunel. Born in Acqueville in Normandy in 1769, even as a boy, Brunel showed a talent for technical drawing, mathematics and mechanics. A staunch royalist, in 1793 he fled to America to escape the excesses of the French Revolution, and soon became chief engineer of the city of New York. In the United States, Brunel worked on a wide range of construction projects. In 1799, Marc-Isambard Brunel arrived in England. A few years later, he was commissioned with a task which, after 2 attempts ended in failure, was thought to be impossible: the construction of a tunnel under the Thames. In order to tunnel safely beneath the Thames, Brunel had to develop a totally new technique. He invented a shield, which also enabled large-diameter tunnels to be dug in soft ground. Brunel drew his inspiration from the shipworm, which isn't actually a worm at all, but a clam. The shipworm, which causes tremendous damage to ships' hulls and piers made of wood, has 2 parallel rows of teeth. These serve as a drilling organ, which enables the shipworm to eat its way through the wood. It then exudes a calcareous secretion, which strengthens the walls of its burrow. Brunel's shield was a kind of rectangular, open-ended steel box, which was driven horizontally through the earth. Workers at the front removed the debris and shifted it to the rear. When new space had been created, the tunnelling shield was pushed forward. In this way, the tunnel was built bit by bit, with the men fairly well protected from collapses. The cavity emerging behind the shield was lined with bricks. With this method, Brunel managed to build a 400-metre-long tunnel under the Thames linking Wapping with Rotherhithe. But financial problems and numerous technical hitches, like several incidences of flooding, meant that the project took 18 years to complete. When the tunnel was finally finished, however, there was no money left to build access roads, so at first it could only be used as a pedestrian tunnel. Even though Brunel's Thames Tunnel was not an immediate practical success, it still represented a marvellous technical achievement. The technique of shield tunnelling was developed further by an engineer called Peter William Barlow. In 1869, Barlow was commissioned to build the first underground railway under the Thames. He replaced Brunel's box with a circular steel plate. Barlow supported his tunnel not with bricks, but with round steel sections that were bolted together. These elements were the precursors of the tubbings still used in tunnel construction today. The method was refined even further by Peter Barlow's former assistant, Henry Greathead, with his famous Greathead shield. It revealed 2 fundamental improvements: hydraulic presses which drove the shield forwards, and excess pressure which prevented the incursion of groundwater. However, because of the cramped space, the masses of earth still had to be removed by hand, a tough and dangerous task. The section that had been cleared was then lined with cast iron tubbings and any gaps filled with grout. The Greathead shield enabled tunnelling to be carried out at far greater depths. Most of the tubular tunnels lie 12 to 30 metres below the surface, but some lines go down as far as 60 metres. So, with the Greathead method, engineers were far less likely to come into conflict with the dense network of underground supply lines.